Wave particle duality is a famous term which you would have heard of. But what if I say there is a better way to depict the same story? Quantum field theory, or QFT for short, is a theory proposed that states that fundamental building blocks of nature are fields. What are fields? Fields are things made up of a mysterious fluid which is spread all around the universe and is even present at pure vacuum. Particles in this field are depicted as higher vibrations than their quantum state of the field. Now, the standard model particles each have a different field here, and at a certain point in the field, there is a certain value given, which is called the field strength, which is usually zero but can oscillate over time. Now, I would like you to imagine two particles colliding with each other. One is a matter and one is an antimatter. In our case, we are going to take up an electron and a positron. When an electron and positron collide up with each other, they annihilate and produce up photons. But in the quantum field language, what's happening is that the electron field is simply passing up energy to the photon field. A whole new theory has been made on the interaction of the electron and the photon field. It is called quantum electrodynamics, or QED for short, which is the most precise theory ever made. The quantum electrodynamics can be solved by two major ways. The first one is by the perturbation method, which is an approximation guess of the set of equations presented to us. Another is the Feynman diagrams. The Feynman diagrams depict up a large set of equations in just a small peak. The diagram you see above describes up the path of two electrons in a classical manner, which obviously get repulsed due to the same negative charge they possess. The arrows in straight line depict the path of the electron, where the wavy function or the wavy line depicts up a photon getting released. The diagram shows that when an electron and another are at its vertices or the closest point to each other, one electron passes up or transfer a photon to another, which is a classical representation of what repulsion is. Sometimes you would see loops in the Feynman diagrams. Some loops describe up a whole new electron, while the other describe up the same electron transferring up a photon to itself. The loops can be solved by the renormalization method, but let's leave it until you and I both become a professional at it.